Hi everybody, we are currently in I guess it's week 1, and then we're in day 3 here. So turn to your packets. On mine it says we're on page 4 of the packet. So let's just kind of conceptualize what is going on over here. So given the function structure f of x equals a times x squared, so looking at a number being multiplied to our parent function. Generalize how the graph of the parent function is affected when the a value is greater than 1. Okay, so let's do like a quick little number line for ourselves. What happens when we plug in any number over here? Any number over here multiplying into that. So it's kind of like saying we are multiplying a big A, or any number that is bigger than 1. We're not going to include 1 because anything multiplied by 1 is just itself. So a number that's bigger than 1 all the way to infinity. What would that be? Well, if we know that our parent function looks something like this, where we go over 1, up 1, over 2, up 4, over 3, up 9. If we multiply it by something, it's going to change these new heights. Instead of 1, 4, 9, it's going to get skinnier, like so. So if it's multiplying by some value that's bigger than 1, we are going to be stretching the parabola by a factor of a. By a factor of a. I like to think of it as it's getting our parabola really, really thin on liposuction, so it's getting skinny. Let's move on to number 3. Given the structure of function ax squared, it's basically the same problem as this one, but what happens when a is between 0 and 1? Okay, here's our number line. Here's 0 and here's 1. What numbers exist in between these two? Those are fractions or decimals. So what happens when a is a fraction? Well, we're going to do that same idea. If this is our regular parabola, and we used to go over 1, up 1, over 2, up 4, over 3, up 9, and then we multiply those heights by a fraction, they're going to decrease, or it's going to widen it out. This is still a stretch, but we're going to call it compression or compressing. It's becoming flatter, or it's becoming wider. So this is compressing by a factor of a. It's getting wide or wider. Sometimes you'll hear me say it's called fatter. I'm trying to avoid using that language. Instead, I'm just to say wider. What happens when a is less than 0? So here's our number line. Here's 0. What happens when we pick an a value that's underneath? Well, all the numbers in here are negative numbers. So it's saying, when is a negative number? All right, well, here's our parent function. Remember, we go over 1, up 1, over 2, up 4, over 3, up 9. But if we multiply those heights by a negative number, all of a sudden, what used to go up 9 is now going to go down 9. So we're going to go over 1, down 1, over 2, down 4, over 3, down 9. So a negative number is just flipping our fraction or a reflection. So this negative value flips the parent function. So quick review. If the a value is bigger than 1, everything to the right, it's going to make our parabola skinnier. It's going to increase those heights. Instead of over 1, up 1, it's going to go over 1, up whatever your factor of a is. If it's a fraction, it's going to take our parabola and make it wider or more flat, thus compressing the parabola. If we have a negative number, then that's going to flip our entire fraction upside down, or our function upside down. All right, let's see it in action. Letter A for number 5. Let's first talk about the vertex, which is right here. It's where the parabola changes direction. It looks like we're at 3, -2. Our axis of symmetry, it passes through the x-axis at 3, so we're going to write x equals 3. What happened to the function? Well, it used to be over here. Remember, whenever you see a graph, you should probably draw in your parent function to see where it was. So it used to be here in green, and it moved over 3, down 2. So not just over 3, but we're going to say right 3 and down 2. Remember that your function notation is going to be f of x equals x minus h squared plus k. So we're going to make it go right 3, so that means we're going to be subtracting 3. That's where the h goes. And here's our k. If we're going down 2, we're going to minus 2. And write f of x equals that. I can also put that there's a 1 right here because my heights did not change. Over 1, up 1. Over 2, up 1, 2, 3, 4. Over 3, it should go up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So because it had the same heights, H-E-I, heights, it didn't have any stretch. So it just has an a value of 1. Now you didn't have to write that 1, you can just write x minus 3 squared minus 2, and that would also be correct. All right, let's take a look at E. Let's put in our parent function. It used to be right here. So what happened? So right off the bat, I know that it's facing downwards, so there was a flip. That means we have an a value that's a negative number. My vertex is at -2, 1. If I were to draw in my line of symmetry, which is the mirror line, it passes through the x-axis at -2, so I put -2 here. Let's check the heights. It looks like it goes over 1, down, 3. Over 2, now it used to go down 4. Let's see how much it goes down now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It doesn't really touch through there. So let's focus on this one. It used to go over 1, down 1, but now this part right here looks like it goes over 1, down 3. So from the -1 to the -3, it looks like it's multiplying that by 3 values. So a value of a, or 3. So our a is 3. So we've got a stretch of 3. It also went left 2, up 1. All right, you guys ready for this? If it goes left 2, that means we're adding 2 to the x. It went up 1, so I'm going to add 1. I know that the a value is negative, and it had a stretch of 3. So that's our new function. Don't forget to write f of x equals. I always forget that part. As long as you remember to add it in at the end. All right, letter F. It's facing upward, so it means our a is positive. It stayed at 0, 0. When I say it, our vertex stayed at 0, 0, so there's no left or right movement. It didn't flip upside down, but let's check our heights. it used to look like this. So this is the original. It got wider. So it's got wider, or it's got compression. If it got compression, that means our A value is going to be less than 1, but bigger than 0. So it's going to have a fraction. Let's check our heights. It used to go over 1, up 1, but now it goes over 1, up some fraction. It used to go over 2, up 4, but now it goes up 2. It used to go 3, 9, but now it goes up 4.5. So all my heights have been cut in half. So it used to go over 1, up 1. Now it goes over 1, up a half. It used to go over 2, up 4. Now it goes over 2, up 2. It looks like everything is getting cut in half. That tells me my A value is 1/2. It's cutting all my new heights in half. So we're going to write f of x equals 1/2 x. You could put -0 because there's no side-to-side movement, or +0, there's no up and down movement. Or you can just write f of x equals 1/2 x squared. This graph is very similar to something on the previous page, on page 3. Almost exactly as page 3. So if you compare this one to question 1, number, or letter C, that's exactly the same as this graph. Okay, moving on. Part 6, question 6. Write an equation for each of the following situations, then solve that equation. Russell Westbrook, a pitcher for the Los Angeles Dodgers, has thrown 126 strikeouts so far this season. If he averages 9 strikeouts per game, so we got 9 strikeouts, outs per game, that's an M, or a rate. We normally do that Y over X, so that Y represents strikeouts, X represents games. How many games should he expect to play this person to reach his personal goal of 275 strikeouts? So this value is kind of like our starting amount so far in this season. We're going to be using Y equals MX plus B. We know so far that he has 126 strikeouts. And we know that he's got 9 per game, because X represents games. And that's going to give us how many current strikeouts we're at. So it's saying if he's at Y equals 275 strikeouts, what game are you on? Okay, so we're going to plug in that Y. 275 equals 9x minus 126. We're going to add that value to both sides. And we get 9x equals whatever that is. Oops, this should have been a plus. Making this a minus and making this a minus. Subtract that out, we get 151. I'm just writing down the problem wrong, aren't I? That should have been 275, making this 149. Okay, let's just rewrite that again. 275 minus 126 gives me 149 equals 9x. I'm going to divide by 9 on both sides. I'm going to probably type this into a calculator because I'm going to get a decimal. So it's about x equals 16.556. So if we want to make this many strikeouts, it's going to be at this many games. But does that make sense? Can we play 0.5 of a game? No. So that means he's going to have to wait until the 17th game to hit his goal of that. Because he can't just play 0.5. He's got to play the whole thing. So it's going to be 17 games to hit that goal. All right, now we're moving on to day 4. This is the pre-lesson for day 4. We're going to do question 2. For part 2, it's asking us what value of k, so we're trying to figure out some k value for all of these. That would give us this many x-intercepts. Remember, an x-intercept means passes through the x-axis. So let's start by building our parent function. This is the one that we know how to do very well. Okay, so what do I do with k in order to get 2 x-intercepts? Looking at this picture right now, it tells me that there's only one x-intercept. It just touches that x-axis and then it bounces away. K represents the vertical change. So I'm going to use a tool. This is called patty paper. Patty paper is used to trace something and then we can move it around. So I'm just going to trace my parent function here. You don't have to do this part, just watch along. So this tool is going to let me take this picture and move it around. So I can move it down, up, left, right. I can even flip it upside down if I want to show that it's facing downward with an a value of -1. So like I said, right now it has 1 intercept. But for me to have 2 intercepts, I need to move it downward in a way where it's going to pass through 2 times. So what kind of k value would I need? Well, it would have to be a negative number. Anything that moves it down. So some examples could be k should be -3. If we move it down 3 units, 1, 2, 3, look, it passes through that x-axis 2 times, right there and right there. If I move it down another unit, like down 4, those 2 beautiful points hit my x-axis. All right. What happens when we have a negative x squared? Well, what does the negative x squared do? It just takes your graph and moves it down like that. So if I want to have 2 x-intercepts with a parabola facing downward, I would have to move it up some amount so that it's going to hit that x-axis 2 times. So I would have to have a positive k. For example, k equals 4. So here it is flipped over, and then I need to transform it 4 units up. 1, 2, 3, 4. And there we go. I've got 2 x-intercepts passing through the x-axis. So here's an example. You could have picked any positive k value. All right. Here's my parent function. What do I do with k, up and down movement, if I only want it to touch 1 time? If I only want it to touch 1 time, if I moved it up, my picture's not going to touch the x-axis at all. If I move it down, it's going to touch twice, which is too many times. So what does k need to be if I only want it to touch once and then bounce away? K must be 0, meaning I don't want it to go up or down at all. I just want it to stay right there. It can move side to side and have 1 point touching the x-axis, but as soon as I add a k, whoop, we're never going to touch it. As soon as I subtract a k, whoa, it's going to hit it twice. So if I only want it to touch once, I need k to be 0. Okay, what do we do if we flip it upside down? That's what that -1 is doing. Same deal, right? If I add a k, all of a sudden I'm going to have 2 touches. If I subtract a k, I'm not going to touch it at all. So what does k need to be? K needs to be 0. All right. Back to our original function. What if I want no x-intercepts, meaning it doesn't touch the x-axis at all? What do I do with k? Well, right now it's got 1. If I move it down, it's going to touch twice, so I need to move it up. if I move k up, so if I just add a positive number, it's going to ensure that it's never going to touch the x-axis. So for example, I can say k equals 5. I can move it up 5 units right there, and it's never going to touch the x-intercepts or x-axis. Here we go. What happens if we flip it upside down? Ooh. We flipped it upside down. I want it to have no x-intercepts. So that means I have to move it away from the x-axis, so I got to move it down some. Therefore, it's not touching the x-axis at all. If I moved it up, I'm going to hit it twice. So moving it down will help that. So we need to do a negative k. An example could be k equals -1. If I move it down 1 unit, it's not touching my x-axis at all. Okay, number 3. All right, number 3. So determine the dimensions of a rectangle with a perimeter of 40 meters and an area of 96 meters squared. So here's my rectangle. It's an h by a b. I know that h is on both sides and b is on both sides because a rectangle has equivalent opposite sides. So here are the 2 equations I've made. Perimeter goes to 40, so I'm just adding, not 2 a's, but 2 h's and 2 bases. Since all these numbers are divisible by 2, I can rewrite that as h plus b equals 20. I just divided by 2 everywhere. Divide by 2, divide by 2, divide by 2, and I got that. So now it's my job to figure out h times b, should be an h times b equals 96. That would also work for this equation. So let's think of all the factors of 96. I'm just going to use this space up here. I know 1 times 96 works, but 1 times 96, if I were to add them together, I get 97, which is not equal to 20. Then I'll do 2. 2 times what gives me 96? That would be 48. But 2 plus 48 does not equal 20. That gives me 50, so that doesn't work. 3 times what gives me 96? That would be 32. But 3 plus 32 does not give me 20, so that one doesn't work. 4 times what gives me 96? 4 times what gives me 96? Let's see. 4 times 24 gives me 96, but 4 plus 24 does not give me 20. Let's keep going. I don't think 5 is a factor of 96, so I can't use 5. Let's do 6 next. 6 times 16 gives me 96, but 6 plus 16 gives me 22, which is not equal to 20. Next one. 7 is not a factor of 96, so we will do 8. 8 times what gives me 96? 8 times 12. 8 plus 12 gives me 20. So that means the dimensions for this one, the only ones that work, are 8 by 12. Let's check it. 8 plus 12 gives me 20. 8 times 12 gives me 96. So I found the only possible situation where it's going to work. You could have kept doing this down and you would have not found another value that works. Okay, let's move on to number 5. We're just going to be talking about this formula and what is everything that it does. So what is the vertex? Well, H and K tell you how the shape moves. If it was at 0, 0, if you go up, down, left, or right, it tells you where our new vertex is going to be. So if we are subtracting H, it's moving to the right. If we are adding H, it's moving to the left. If we are adding K or subtracting K, that's basically telling you how does 0, 0 become its new location. Remember this phrase? Change H, keep K. We're going to change h, making it plus h. We're going to keep the sign of k. So if I was ever asking you to find what is the vertex, you're going to change h, keep k. Let me just do like an example for this piece. I see a 5 and a 98. So my vertex is going to be 5, 98. I changed the value of h, I kept the value of k. I could do this one too. Vertex is, if it was a positive 4, it becomes a negative 4. I'm going to keep k, negative 24. Now, this question is not asking you to find the vertexes, but I just wanted to show you that you change the value of h, keep the value of k. What is the equation of line of symmetry? Well, when we have a parabola, and we call that h comma k, wherever it winds up being on the graph, if I drew a line down the middle, it's going to hit the x-axis at h. So I would write x equals h. How can you tell if the parabola opens up or down? We're going to look at A. If it's a positive A, opens up. If it's a negative A, opens down. How can you identify the dilation? Dilation is another word for stretch, which is, again, look at A. I'm running out of room here, so I'm going to write off to the side. If A is bigger than 1, it's going to be a stretch. If A is less than 1, I'm going to give myself enough room. If A is less than 1 but bigger than 0, it's going to be a compression. And if A is negative, we already talked about that. So if it is a stretch, it means we're getting tall and skinny. If it's compression, it's getting wide. Cool. And that's it.